Okay, so you hear about climate change all the time, right?
Okay.
Yeah, it's hard to miss. Maybe you've even noticed some, I don't know, weird weather lately.
Yeah, it's definitely in the conversation.
But look, today we're going deeper than just the headlines. We want to really get into the fundamental shifts happening to our planet.
Exactly. We're talking about climate change, which, means those big long-term shifts in temperature and weather patterns over decades or even longer.
Right. It's crucial to remember this isn't just about whether it's raining today or sunny tomorrow. That's weather.
Precisely. This is the bigger picture, the long game.
And okay, Earth's climate has changed before. We've had ice ages, warmer times, that's natural.
True. But what's different now, and this is what bodies like the UN and NASA really stress,
Yeah.
is the speed. Since the 1800s, things are changing incredibly fast, and the science overwhelmingly points to us. Human activity.
Mostly burning fossil fuels,
Mm.
coal, oil, gas, that kind of thing.
That's the primary driver, yes.
Yeah.
The evidence is really strong on that.
So how much warmer are we talking?
Well, right now, the Earth's average surface temperature is about 1.2 degrees Celsius warmer than before the Industrial Revolution.
1.2 degrees. That maybe doesn't sound huge to some people.
It might not, but globally, it's significant. Think about it this way. Data from places like Copernicus and NOAA just confirmed January 2025 was the warmest January ever recorded globally,
Wow.
and likely warmer than any January in the last 100,000 years. That kind of puts the scale into perspective, doesn't it?
It really does. Okay, so our mission for this deep dive then is to unpack how this is happening, the mechanics of it, and look at the real-world effects, give you a solid foundation.
Let's do it. Understanding the mechanism is key.
So where do we start? How does burning fuel actually warm the whole planet?
Okay, it basically boils down to something called the greenhouse effect.
Right. Heard of it.
Imagine the Earth wrapped in a sort of blanket. That's our atmosphere.
Okay, got the blanket analogy.
Now, within that atmosphere, there are certain gases. Carbon dioxide, CO2 is the main one we talk about, but also methane, nitrous oxide.
The greenhouse gases.
Exactly. And these gases, they act like that blanket. They trap some of the sun's heat that bounces off the Earth's surface.
And that's normal.
Yeah.
Necessary, even.
Absolutely necessary. It's a natural process. NASA points out that without this natural greenhouse effect, Earth would be freezing, like minus 20 degrees Celsius on average. Way too cold for us.
Okay, so the effect itself is vital. Where did it go wrong?
Well, the problem started around the 1800s with the Industrial Revolution. We began burning massive amounts of fossil fuels.
And that released more of these greenhouse gases.
Precisely. We started adding much more CO2, methane, and others into the atmosphere. So going back to the analogy,
We've made the blanket thicker.
exactly, we've thickened the blanket, trapping more heat than is natural. And that's causing the overall warming trend.
And CO2 from burning coal, oil, and gas for electricity, heating, industry, cars. That's the biggest piece of this thicker blanket.
It is. Carbon dioxide is the primary contributor to this enhanced greenhouse effect.
Yeah.
Our energy use, our transport, a lot of industrial processes,
Mm.
they're the main sources.
But it's not only burning stuff, right? I remember reading about forests, trees.
You're absolutely right. Deforestation is another big factor. Trees are fantastic because they absorb CO2 as they grow. They pull it out of the air.
Carbon sinks, they call them.
Yeah, exactly. So when we cut down large areas of forest, we lose that absorption. Plus, often the wood rots or is burned, and the soil gets disturbed, releasing even more stored carbon back into the atmosphere. Double whammy.
Okay. And what about methane? You mentioned it earlier. It seems like CO2 gets all the attention.
It does, yeah. But methane, CH4, is important too. There's less of it overall compared to CO2.
Dude.
But molecule for molecule, it's much more potent at trapping heat, especially in the short term. Like over 20 years, it's way more powerful than CO2.
And where does methane mostly come from?
Big sources are agriculture, especially livestock like cows, and also the decomposition of waste in landfills. Natural gas leaks are another source.
So we're pumping out CO2, cutting down trees that absorb it, and releasing potent methane, too. How unusual is this amount of greenhouse gas in the atmosphere, historically speaking?
That's maybe the most crucial point. It's completely unprecedented in recent geological history.
How far back are we talking?
Well, data from ice cores and other sources, referenced by groups like the British Geological Survey and the UN, show that current CO2 levels are higher than they've been for at least the last 750,000 years.
750,000 years.
Yep. Longer than our species, Homo sapiens, has even existed. We've basically supercharged the natural greenhouse effect to a level the planet hasn't seen in an incredibly long time.
Okay, that really paints a picture. So the planet's warmer because of this thicker blanket, but you said it's more complex than just everything getting a bit warmer.
Yeah.
What are the knock-on effects?
Right, because Earth is a complex, interconnected system. You change one major thing, like the global temperature, and it triggers cascades of other changes. It's not just about slightly warmer summers.
Like the extreme weather we keep hearing about.
Exactly. That's one of the most direct consequences. We're seeing more intense droughts in some places, leading to water scarcity.
And then floods in others?
Yes, heavier rainfall events leading to really catastrophic flooding. And warmer oceans provide more energy for storms, so we're seeing stronger hurricanes and cyclones.
And the sea level rise. That seems really concrete. You can measure that.
You absolutely can, and it's happening for two main reasons. First, ice sheets. The massive ones in Greenland and Antarctica are melting at an accelerating rate, pouring water into the oceans.
And the second reason?
Thermal expansion. Simple physics, really. As water warms up, it expands, so the warmer the oceans get, the more space they take up.
And that directly threatens coastal areas.
Hugely. Coastal communities, entire ecosystems like wetlands and mangroves,
Yeah.
they're under threat. For some low-lying island nations, it's an existential risk. They might literally have to relocate their entire populations.
It's hard to even imagine. What about the natural world? Plants and animals, how are they
Yeah.
coping?
They're struggling. Ecosystems are finding it very hard to adapt quickly enough.
Like the coral reefs.
Coral bleaching is a stark example, yeah. Warmer ocean temperatures stress the corals, causing them to expel the algae that live within them, which they need to survive. Earth.org highlights this devastating impact on marine biodiversity.
So the whole ecosystem collapses.
Pretty much. Reefs support a huge amount of marine life. We're also seeing habitats, shifting plants and animals trying to move towards the poles or up mountains to find cooler conditions, but many just can't keep up, leading to a decline in biodiversity.
And how does this all circle back to us, to people, beyond just, living by the coast?
Oh, it impacts us in countless ways. Think about health. More intense heat waves mean more heat stress, heat stroke. Warmer conditions can also allow disease-carrying insects like mosquitoes to expand their range.
Okay, I see.
Then there's food production. Changing rainfall patterns, droughts, heat waves, they all make farming more difficult and unpredictable, threatening food security in many regions. And safety, obviously, from extreme weather. Plus, there are huge economic costs associated with damage from storms, floods, dealing with droughts, adapting infrastructure. It all adds up.
Can you give a specific example, something maybe relatable?
Sure. Think about, say, wine producers. Even in places like New York's Finger Lakes region, they're already dealing with challenges. Changes in temperature and rainfall affect the grapes when they ripen, their sugar content, their acidity. They're having to adapt their practices, maybe even consider different grape varieties. It hits local economies directly.
That really brings it home. So
Yeah.
the picture is, well, it's serious. What does the science say we need to do? What's the target?
The overwhelming scientific consensus really crystallized in the big UN reports from the IPCC, the Intergovernmental Panel on Climate Change,
Okay.
is that we absolutely need to limit global warming to 1.5 degrees Celsius above those pre-industrial
The
levels.
1.5 target. We hear that a lot. Why 1.5?
Because the science indicates that beyond 1.5 degrees, the risks of really catastrophic, irreversible impacts increase dramatically. Think widespread ecosystem collapse, extreme sea level rise, massive disruptions to food and water supplies. 1.5 is seen as a critical guardrail.
And getting there. What does that involve?
It involves incredibly steep and rapid cuts in greenhouse gas emissions. We're talking about nearly halving global emissions by 2030. That's less than a decade away.
Having emissions by 2030, that sounds huge.
It is huge. It requires a massive fundamental shift across the entire global economy, moving away from fossil fuels towards clean energy and changing practices in industry, agriculture, transport, how we build things, everything.
That sounds like an immense challenge, especially getting every country on board. What are the roadblocks?
Well, you've hit on a key one. International cooperation.
Yeah.
Getting nearly 200 countries to agree and, more importantly, act decisively is incredibly complex.
We have the Paris Agreement.
We do. And that was a landmark achievement adopted back in 2015. It sets the goal of keeping warming well below 2 degrees C and pursuing efforts for 1.5 degrees C. Under Paris, countries submit their own national plans, called Nationally Determined Contributions, or NDCs.
But are those plans enough?
Right now, no. If you add up all the current NDCs, they still put us on a path to significantly more warming than 1.5 degrees. So there's a big gap between the ambition and the current reality of national policies.
And politics gets in the way too, I imagine.
Absolutely. Political shifts within countries can have big impacts. We saw the U.S. pull out of the Paris Agreement under one administration and then rejoin under the next. That kind of volatility makes long-term global planning
Yeah.
difficult.
What about just confusion?
Yeah.
Or people deliberately muddying the waters?
That's a huge challenge, too. Misinformation and disinformation about climate science and climate solutions are widespread, and they actively work to undermine public understanding and the political will needed for strong action. It sows doubt and delays progress.
Okay, so it definitely sounds tough. There are serious headwinds. Is there any good news?
Yeah.
Any reason for optimism?
Yes, absolutely. Despite all those challenges, and they are real, there are definitely positive signs and growing momentum. It's not a hopeless situation by any means.
Okay, good. Tell me something positive.
Renewables. Renewable energy is booming. Solar and wind power have become dramatically cheaper over the last decade or so.
Cheaper than fossil fuels.
In many places, yes. They're increasingly the most cost-effective option for new electricity generation. The International Energy Agency, the IEA, projected that renewables are actually set to cover all the growth in global electricity demand this year in 2025.
All of it. Wow.
And IRENA, the International Renewable Energy Agency, reported something like a 15% jump in global renewable capacity just last year in 2024, mostly driven by solar. Even countries that traditionally rely on oil exports are investing heavily in renewables now because it just makes economic sense.
That is a massive shift. What about other technologies?
Yeah, innovation is happening across the board. Electric vehicles, EVs, are becoming much more common and capable. Battery technology is improving rapidly, which is key for storing renewable energy for when the sun isn't shining or the wind isn't blowing.
Right, storage is crucial.
Totally. And also, things maybe less flashy but important, highly energy efficient appliances, things with labels like Energy Star, LED lighting has become standard using way less energy. And things like heat pumps for efficient heating and cooling are taking off.
So the tools are there, or getting there.
Yeah.
What about political will and public awareness? Is that shifting too?
I think it is, slowly but surely. While the big international agreements have their challenges, they do provide a framework. And beneath that level, you see a lot happening.
Like what?
More and more cities, regions, states, and even major corporations are setting their own ambitious climate targets, aiming for net zero emissions.
Net zero means?
Meaning, they aim to reduce their greenhouse gas emissions as much as possible and then offset any remaining emissions, for example, by planting trees or using technology to capture carbon. So the net effect is zero emissions.
Got it.
And you absolutely cannot discount the impact of public awareness and activism, especially from young people. The youth climate movements have really pushed the issue up the agenda and increased pressure on leaders to act.
That brings up a question people often ask. Does what I do actually matter? My individual choices versus these huge systemic problems.
It's a really important question. And the answer is yes, absolutely. Individual actions matter, especially when they add up collectively.
So what kind of things make a difference?
Things like reducing your energy use at home, better insulation, efficient appliances, turning things off, choosing to walk, bike, or use public transport instead of driving when you can. Thinking about your diet, reducing meat consumption, especially red meat, has a significant impact because livestock farming is emission intensive. Wasting less food is another big one because food production and transport generate emissions, and rotting food in landfills releases methane. And just generally consuming less stuff, buying things made to last, repairing rather than replacing.
Does that also send a message? Beyond just my own footprint.
Definitely. Your choices signal demand to businesses. If more people choose sustainable products or demand lower carbon options, companies notice and adapt. Groups like Greenpeace or the David Suzuki Foundation often have great resources on impactful actions.
It's not just about individual actions, is it?
No, and that's crucial to emphasize. Individual changes are important, but they need to go hand in hand with pushing for bigger systemic changes from governments and industries. Voting, contacting elected officials, supporting organizations working on policy change, that's essential too. We need both bottom-up and top-down action.
Okay, so let's try and pull this together. We've covered a lot. The core idea is
Yeah.
climate change is real. It's a major long-term shift.
Driven primarily by us, the human-caused greenhouse gas emissions thickening that atmospheric blanket.
And it's already causing serious impacts around the world. Extreme weather, rising seas, ecosystem stress.
But, and this is the important but, we do have solutions. It's not game over.
Right. Renewable energy is surging, technology is advancing, awareness is growing. There's momentum.
There is. The challenge is immense. The time scale is tight. But the pathway exists if we choose to take it collectively.
So thinking about that collective action and the interconnectedness you mentioned, here's something maybe for you, the listener, to mull over. If you think about your own local community, what single change, if lots of people adopted it, do you think would have the biggest positive ripple effect for tackling climate change?
That's a great question. Thinking local, acting global in a sense, what lever in your community could make the biggest difference?
Something to ponder. Now, next time on the deep dive, we're going to focus specifically on our oceans.
Yeah, we'll be looking much closer at how climate change is profoundly affecting marine ecosystems, sea levels, and ocean chemistry. It's a critical piece of the puzzle.
We really hope you can join us for that.
It's going to be an important discussion.
Until then, keep thinking, keep asking questions.